Welcome and thank you for joining today's webinar. During the webinar, we will be discussing landfill leachate management using advanced membrane technology. This new membrane technology can help those using RO membranes to reduce cleaning, lower OPEX, and improve sustainability. So today's webinar will be presented by ZwitterCo's Myron Van Eert, Brett Thompson, and myself, Elka Pertzagali. We also have a very special guest joining us today, Edel from Serpol. Christy Harner is also going to help us at the end of the webinar with the Q&A session. So without further ado, let's dive into the discussion. Myron, please take it away.
Thanks, Elka. And welcome and thank you to all of you for joining us to attend this webinar. Given we likely have a pretty diverse audience, I'll start by setting some context and definitions to guide our discussion. Firstly, a landfill is defined as an area of land or lined excavation where a waste material is deposited or held for permanent storage. These structures may be open or covered, but they are permeable to water or rainfall. Leachate is then defined as the wastewater that is formed when water percolates through the waste in the landfill. As this water passes through the landfill, it draws out or leaches chemicals or constituents from the water or from the waste. The result is a wastewater stream that now contains a wide variety of chemicals and pollutants, including inorganic and organic components, color, heavy metals, and contaminants of concern such as PFAS and related compounds. Due to the chemical mix and toxicity of that leachate management is critical so as to comply with environmental and regulatory standards, enable water reuse or safe discharge, and to minimize disposal costs such as hand hauling or sending to a publicly owned treatment facility or processor. Now, for the full audience, this part will do a little bit of an online poll. If all of you could kindly take a moment and make a selection on one of the three options around what your main challenges and goals are with landfill leachate treatment. So the first one is meeting tightening regulations. The second is reducing operating costs. And the third is reducing downtime. So if everyone could just take a moment, please, to submit your answers. We'll get to the overall results here in just a few moments. Hopefully we have a broad group here with varying interests. We'll see what the results come out to. So we have across the tabulation that came in, one, meeting tightening regulations is very prominent. Two, reducing operating costs, and third is reducing downtime. So great to see that breakdown and profile across the audience. I'm confident we will hit on a number of these items throughout the webinar. All right, nextly, when it comes to leachate management, there are effectively two ways to handle landfill leachate. One is to haul the leachate to an offsite treatment facility, which is typically a POTW. This is very common in North America. But there are changing dynamics, such as higher cost of transportation, as well as rising regulatory concerns regarding the leachate itself. Although the volume of leachate is relatively small for a POW or other processor, the nature of the high-strength stream, such as those heavy metals, those organics, nutrients, notably PFAS and those other related compounds, may present a challenge for that given POTW or processor and could be have further challenging situation in the future as well. As a result, trucking costs, distances, tipping fees, and all are increasing and becoming more difficult in which to manage. And secondarily, there's the option to treat the leachate on site for reuse or compliant discharge and effectively close loop the operation. This is a very common practice that we see outside of North America, but given some of the changing trends, likely will become more prominent in North America as well. When you look at landfill leachate treatment, There's typically a couple different types of flow sheets that you'll see or come into. So the landfill leachate will go into a pretreatment step, which is largely to take out suspended solids or other large particulate, and then it'll go down a couple different pathways in which it can be tackled. So first one is utilizing biological treatment, followed into ultrafiltration, then with reverse osmosis at the final. Second one might just be biological treatment, moving into an RO treatment stage. The third one is the use of superfiltration, which is a ZwitterCo specific technology pretreatment, then followed into reverse osmosis. And then the third might be if the solids are light enough and such, it might be able to go straight to RO. And all of these outcomes in treatment schemes, you wind up getting two flows. One is the permeate or purified water, which can be evaporated, or can be reused or sent to discharge. And the other is the residual or the retentate, which may go back to the landfill. It could go for hauling, or it could go for some other further treatments, such as evaporation. All right, and specific when it comes into leachate and putting these different treatment schemes in place, PFAS and related compounds are ever facing increasing focus and scrutiny and need to be accounted for across all the flow sheets. RO membranes are universally accepted as a highly effective PFAS separation and concentration technology. So you typically see them in all. Even if a flow sheet uses an alternative treatment, like for example, foam fractionation, RO is a very common and needed complement as part of that PFAS separation stream. Technologies like RO and foam frac are used to separate and concentrate PFAS, which then enables more efficient and economical downstream treatment with other technologies such as electrooxidation or any of the number there that are listed as well. So definitely lots of focus and lots of attention around the PFAS components in leachate. All right, so just to summarize, in landfill leachate, you've got all the treatment schemes incorporate reverse osmosis in them to effectively reduce those constituents such as ammonia or PFAS, heavy metals, all the organics and such that are in that stream. So RO plays a very critical role in that treatment and process. And any of these treatment flow sheets absolutely require pre-treatment to remove the suspended solids and other larger constituents, and then rely on the workhorse of membranes, RO, to remove the smaller molecules and dissolve contaminants in order to give a dischargeable or reusable treatment scheme or flow sheet. All right, so we'll do our final poll with everyone. So if you could kindly give a designation as to what profile this fits for you. So the first one would be your landfill operator. Second option would be equipment manufacturer or service provider. Third would be consulting engineer, or the fourth would be some other category there. So if everyone could kindly, all right. So it looks like we've got a good composite of landfill operators, end users, some equipment manufacturers and service providers, a good grouping of consulting engineers, and then a large group of other, of which, given the content that's coming up, hopefully we'll hit and be on mark across all the different people currently in the webinar. All right, fantastic. I am going to turn this over to my colleague, Brett. So Brett, the floor is yours.
All righty, thanks, Myron. So Myron went over a couple of the different potential leachate treatment schemes, but we're going to go ahead and dig a little bit deeper into one possible treatment scheme. In this scenario, you have the landfill leachate, which is collected from the bottom of the landfill, and it's typically pumped to either a collection pond or a storage tank. From there, you would need a pre-treatment, usually solids, for suspended solids removal. This could consist of, we show a guard filter here, so that could be a cartridge filter, that could be a multimedia filter followed by a cartridge filter, it could be some other sort of continuous solids removal. But the general purpose here is to remove larger solids prior to a membrane-based process. We show superfiltration as the next step, which Myron alluded to. This is optional. This is more for really high strength leachate, where you might have fats, oils, and grease, higher levels of smaller suspended solids that aren't removed very easily with cartridge filtration. This would be mostly for high strength leachate. From there, you would go to your RO system. RO systems for leachate are typically multiple passes in order to meet those discharge limits. It sort of depends on what your final goal is for treatment. If you're trying to discharge to a surface water, you might need to remove ammonia, for example, to lower levels, less than 5, 10 ppm. Boron can be difficult to remove, and it often shows up in permit discharge limits. PFAS, of course, and of course, most limits will also have some sort of organic limit in your discharge. So the first pass of the RO system is the pass that sees the highest strength leachate, because it's only been, in this scenario, pre-treated with solid removal up to that point. So it'll also have high levels of TDS, which means it'll require high pressures in order to sufficiently get high recovery rates and squeeze out as much clean water as possible. And so this means the first pass is also the most susceptible to organic fouling, which we'll talk a bit about on the next upcoming slides. From there, the residual from either the superfiltration or the RO can be sent back to the landfill. So you're effectively dewatering the landfill. Or it can be sent to an evaporator, some sort of thermal solution for further volume reduction. And even from then, you could go to something like a crystallizer if you really wanted to get solids. But from there, usually that slurry is either sent back to the landfill or disposed of elsewhere. So organic fouling, I kind of alluded to, is the accumulation of organic material on the membrane surface. So you're pressurizing organics into these RO membranes, and over time, you can actually get irreversible organic fouling where you're unable to remove those foulants with cleanings. So some of the photos on the right here show some examples of different membrane technologies that have seen irreversible organic fouling. Spiral wound membranes, hollow fiber membranes, they're all susceptible to the same irreversible organic fouling. And so, like I said, to prevent this from happening, typically you would clean your membranes before it gets to this point. But there's a lot of costs associated with cleaning membranes. So you have chemical usage. You could be using formulated cleaners, which could be expensive. A lot of landfills clean their membranes at least once a week, sometimes as often as every day, depending on how bad the fouling has gotten. Because you're cleaning, you're actually, over time, degrading the polyamide surface of the RO membrane, which could cause your salt passage to increase. And eventually you could have difficulty meeting discharge limits especially for things like ammonia or boron, and things that are somewhat difficult for RO to get to low level limits. Of course, if you get to this point, you also need to replace the membranes if you can't recover anymore with the cleaning. So there's a cost associated with that. And then downtime, there's a cost because often you'll have an operator that might not be their full-time job just to clean membranes. They might be doing other landfill operations. So it's their time. And then also, if your system's down for cleaning, that means that you're no longer lowering the level of water in your storage tanks or your ponds. So it could eventually accumulate, and you would need to treat the leachate in a different way by hauling, most likely. So this is what I mentioned. A lot of landfills clean usually once per week or more often, and replacing elements around every 1 year or even more frequently. So membrane fouling has been a long-standing challenge in the membrane industry. Like I mentioned, it It leads to increased operating expenses, shortened membrane life. Because it's been such a problem for such a long period of time, other membrane manufacturers have been trying to come up with different ways to handle that. So some of the solutions are low fouling or fouling resistant RO membranes. Typically, these consist of a coating on the surface of the membrane that helps prevent fouling, but could eventually wash off of the surface. Or they use advanced feed spacers that might have unique geometries or thicker openings, wider openings. But ultimately, these can also still be subject to irreversible organic fouling. And with that, we'll go into our next poll question, which is, do you currently use RO membranes? Yes, no, or no, but I'm interested in using them. Poll response, pretty even split. Yes, between yes and no, and then a couple of people that are interested. That's great. So because irreversible organic fouling is still a great challenge, membrane manufacturers have been, and researchers have been looking for ways to produce a step change, revolutionary, new way to handle organic fouling. One of these new chemistries relies on zwitterions. So zwitterions are small organic compounds that have an equal number of positive and negative charges. They are extremely hydrophilic or organic repelling. And people have been trying to incorporate these into membranes for decades. But zwitterions are hydrophilic to the point of being hygroscopic. So they're very difficult to handle. They actually wick moisture out of the air. And so if you try to incorporate them into a membrane, usually it would result in a sticky membrane or something difficult to handle. So the real revolutionary change here was incorporating it into a hydrophobic copolymer backbone, which provides structure and actually allows for these zwitterionic copolymers to self-assemble into a pore structure. And so this pore structure actually repels organics, not just on the surface, but actually throughout the pore structure. So even after filtering difficult wastewaters for like landfill leachate, you can still remove the foulants with a cleaning. And so we have a video here just to kind of show a zwitterionic membrane in action. This is a membrane that's been fouled with an organic brown material. And this is just a demonstration to kind of show that these organic foulants don't stick to the surface. This was actually removed with just a clean water flush, no high pH cleaning was used. So this is just a demonstration that sort of shows what zwitterionic membranes can do. And with that, I will turn it over to Elka.
Thanks, Brett. As Brett mentioned, ZwitterCo has developed a new material chemistry that offers unprecedented fouling resistance. By using this membrane in landfill leachate treatment applications, end users can benefit from a significant reduction in alkaline or high pH cleanings and fewer element replacements, which results in huge cost savings. So let's dive into some of the benefits in more detail. So the first is save money. By using a membrane that doesn't allow for organic material to adhere to the membrane surface, you won't have to clean as often, which means you'll benefit from less downtime, less cleaning, less chemicals, and or less waste hauling. The second is longer element life. Cleaning chemicals, specifically alkaline or high pH chemicals, deteriorate membrane chemistries. Because ZwitterCo RO doesn't require as many alkaline cleanings, the membrane won't degrade as fast as conventional membranes, meaning they will last longer. Operate with peace of mind. With the world's most fouling resistant RO, you can have peace of mind and not worry about unplanned system downtime due to fouling events and focus on other responsibilities. Additionally, because less cleaning is needed, sites may also benefit from having to handle or store less chemicals. restore performance. Biology and other organic material cannot stick to or grow on the zwitterionic surface, meaning cleaning will easily recover performance. And last but not least, it's an RO element, but much better. ZwitterCo RO elements are designed in the same industry standard sizes you're used to, meaning it's an easy drop-in replacement. No new equipment or system modifications are required to implement this technology. So with that, let's look at some landfill leachate case studies using ZwitterCo RO membrane elements. So the first site is a landfill in the US. The site collects leachate in a pond on site and uses an RO system to treat that leachate so that the pond doesn't overflow, specifically during the rainy season. This site was historically replacing their conventional RO elements every other day due to rapid fouling. So the organics were settling on the membrane surface, causing the system performance to decline quickly. And that organic fouling in the system caused the system to lose permeate flow. Because the fouling at the site was so severe and they were replacing elements every other day, the site chose to implement ZwitterCo RO elements. By implementing ZwitterCo RO elements and by making a few operational modifications, the site saw some immediate benefits. They were able to run for 7 weeks without any element replacements. And due to less fouling, more stable operation, and less frequent element replacements, the site was able to significantly reduce their operating costs and are looking to install ZwitterCo RO elements in other leachate treatment systems at other landfills. Another site in the second largest city in France was using a 2-pass RO system in order to treat their landfill leachate to meet discharge requirements. The site was cleaning the first pass of their RO system every other day and replacing elements every 2 years. Because they were using formulated cleaners, this was costing them significant amounts of dollars. By installing ZwitterCo RO elements in the first pass, where they were seeing the majority of the organic fouling occurring, the site benefited from only performing 1 chemical cleaning in the first 2 weeks of operation. Since then, the site implemented preventative cleanings every week to ensure reliable operation. But because things were going so well, they pushed out those preventative cleanings to every 10 days. By reducing the cleaning frequency from every other day to every 10 days, the site was able to reduce their cleaning frequency by over 80%. Needless to say, the site was very happy and have said that less chemicals, longer run times, and less maintenance have made it much easier for their team to operate the system. For this next case study, I'm pleased to introduce our guest speaker, Edel from Serpol. Alain is an engineer with Serpol, a systems integrator in France, specializing in effluent treatment for industrial and landfill leachate. He has over a decade of experience managing landfills, designing and building new units, and exploring innovative products such as ZwitterCo RO membranes, which he has helped install in various sites in France. Alain is going to review a site in which Serpol used ZwitterCo RO elements to treat a low-strength landfill leachate. Alain, the floor is yours.
Thank you, Elke. So first of all, sorry for my accent. As Elke say, I'm French, so I'll try to speak clearly so you can understand me. But I wanted to talk about our feedback using ZwitterCo reverse osmosis membrane for treated landfill leachate. The site I'm going to talk is owned by a small municipality called Citreval. It was a small landfill that ceased operation in 2013. At that time, leachate was stored in a pond and it was just hauled by truck to the local municipal wastewater treatment plant. In 2017, the municipality launched a public tender, which has 2 main goals. First one, as always, was to reduce the treatment cost of the leachate. And the second one was to limit the consumption of drinking water that was used for residual on-site activities like truck washing or dust removal. It was a tender for build, design, and operate contract. So Serpol was awarded this contract with a solution mainly based on a low pressure reverse osmosis, combined with some prefiltration, like Brett talked about, and a final disinfection by UV for reuse of the water on site. So since the beginning of the operation of the plant, the reverse osmosis has very, very bad performance issues. We would observe steadily increased pressure that require daily membrane cleaning, which had a very significant impact on the cost of the operation. We are needed to clean every day our membrane, which has an impact on the membrane life, and we had a very low recovery rate, so we were producing more concentrate than what we were expected. So Serpol has run a membrane autopsy of one of those elements, which has revealed mainly an organic fouling. So we tried different solutions, like using biocide, specialized cleaner with surfactant, or different type of membrane, but none of those solutions delivered any results that were convincing enough. So in early 2024, we decided to test the ZwitterCo membrane. Since our reverse osmosis unit was consisting of 3 pressure vessels in parallel, we decided to compare ZwitterCo membrane with the other brand that we were using. So we installed one vessel with ZwitterCo elements, and the 2 other vessels were using high rejection membrane by a different supplier. And we have run this test during 2 months. We that show, well, you can show on this graph the flux, so the production of permeate per square meter. During the time of the test, we have run the test for only 2 months because, as you can see on the red curve, that the flux was decreasing more and more, and we had to stop because we weren't meeting our performance engagement with our contract. But on the green curve, you can see the ZwitterCo elements. The flux was quite constant during that time, and we didn't show any decrease. So we decided to try ZwitterCo elements on the 3 different pressure vessels. We are running the ZwitterCo elements since 7 months ago, and the results have been very, very positive because we have reduced the cleaning frequency from once a day to twice a week. We didn't change the membrane for 7 months. So before we are changing membrane every 2 to 3 months. So it was a big change for us. And we are now using some more traditional chemical cleaner product like caustic soda or acid chlorhydric. Before we were using specialized chemical product that was a little bit more expensive. And the quality of the permeate is still good enough for on-site reuse, so we didn't have to change anything on the process at all. So yeah, on the site, in summary, we were very happy to change our membrane for ZwitterCo elements since it has helped us to reduce cost and improve overall our treatment performance. And I think that's everything I had to say for my part.
Thanks, Alon. Yeah, just to quickly summarize the site that Alon reviewed, this site has a low strength or light leachate, meaning the TDS levels are a little bit lower than some of the other leachate sites that we talked about, which enabled them to use brackish water RO elements. So as Alon mentioned, the site uses RO to treat the leachate so that they can reduce the waste volumes that are hauled off-site for treatment. And by using RO, they were able to reuse the permeate for cleaning and dust control. Because of the high level of organics at this site, they were cleaning their RO system every 24 hours. and replacing those conventional RO elements very frequently, I believe every 4 to 6 months. And during the first months of operation with ZwitterCo RO, the site noticed a slower rate of fouling, as demonstrated by the stable operating flux that Alon just talked about. They were able to reduce the cleaning frequency and cleaning costs. And because of that slower rate of fouling and reduced cleaning, they were able to get longer element life with the ZwitterCo RO elements. So last but not least is another example of a landfill in Europe. This site treats a high-strength leachate and is running 2 trains side by side. One train is using ZwitterCo RO, while the other is using a conventional RO. This particular site has benefited from a significant reduction in chemical costs for cleaning. The conventional RO elements are cleaned using a specialty cleaner, which costs the site 138 euros per clean. The ZwitterCo RO elements, on the other hand, are cleaned using commodity chemicals and only cost 6 euros per clean. So this means the site benefits from up to 23 times lower cleaning costs when using ZwitterCo RO versus conventional RO. In general, ZwitterCo RO elements are proving to significantly reduce the cleaning frequency or cleaning costs at these landfills. By reducing the cleaning frequency from organic fouling, users will experience less system downtime, allowing them to benefit from longer run times and reduced OPEX. So let's take a quick look at an economic model to highlight the potential savings. So let's say we're looking at a landfill leachate site that is similar to the very first example I spoke about, located in France, cleaning every day. Let's also say that the conventional RO elements are lasting about a year because they're dealing with lots of organic fouling challenges and cleaning so frequently. Because this site cleans their RO elements every other day, they're also suffering from significant downtime costs. Their goal is to run for longer periods of time between cleanings, which would also equate to decreased OPEX. So if the site were to install ZwitterCo RO elements, they wouldn't have to clean the system as frequently. So let's assume they cut the cleaning frequency down to about once a week, a 67% reduction in cleaning frequency. By exposing the membrane to less chemicals, the elements will last at least twice as long. So let's say the elements last 2 years instead of 1. Because the ZwitterCo RO elements require less frequent cleaning, less downtime, and last longer, the ZwitterCo RO elements provide a value of over $2,000 per element per year. This is significant. So how do you get started? Because landfill leachate often contains higher TDS concentrations, on the order of 20,000 to 60,000 ppm, for example, they often require elements that can operate at higher pressures. ZwitterCo currently offers 2 different high-pressure RO elements. One features a standard 34 mil feed spacer. The other features a thicker 50 mil feed spacer. As for the systems treating low-strength or light leachate, ZwitterCo also offers standard high rejection and low energy brackish water RO elements. All ZwitterCo RO elements are available in industry standard sizes that fit into standard RO pressure vessels, meaning these elements serve as a drop-in replacement for existing RO systems. Again, no system modifications or additional capital investments are needed to implement this technology. So if you have an existing RO system treating landfill leachate, or are looking to install a system and know your stream will contain higher levels of organic material, consider installing ZwitterCo RO elements to meet your landfill leachate treatment requirements. Maintain stable operation with less maintenance and reduce your operating costs. With that, we will move to the Q&A session.
During the last 40 minutes, we've had some great questions come in. And again, please feel free to add them now, and I'll be going through them to ask the right people the right questions. So I'm just going to get started, and hopefully we get even more questions as we go. The first one that came in was a question around pre-treatment. What is the pre-treatment required before feeding to the membranes? I don't know who wants to answer that. Someone go ahead and pick. Brett, go ahead.
I could cover that. Sure. Yeah. So pre-treatment, we do typically recommend standard 5-micron pre-treatment ahead of the RO membranes. If you have superfiltration ahead of it, then the cartridge filters aren't going to be doing much, but it kind of depends on how much suspended solid levels you have in your feed. But it would be similar, suspended solid pre-treatment that we would expect. So that would be typically 5-micron.
Okay, thanks. We do have a somewhat, more of a cleaning question. So the question is, what do you use for cleaning? Low pH for minerals, high pH for organics, standard cleaners, custom, and then do you have to do low pH before high pH?
I could cover that as well. So we typically recommend cleaning with just commodity chemicals. So it'd be sodium hydroxide, caustic soda for the high pH cleaning. We do usually recommend doing the high pH cleaning first because that'll help remove any organics on the surface and get access to the scale at the underneath if there is any. So landfill leachate, oftentimes you'll see metal oxides, iron, manganese, and for that, in acid cleaning at a lower pH, you could just use hydrochloric acid or sulfuric acid. But yeah, you would just use commodity chemicals for that, and that's what we kind of recommend for all. I think all of the case studies that we had shown were done using commodity chemicals.
Okay. Great. So there's another question just popped up. Do you supply seawater membranes?
I can take this one. At this point, we do not have a seawater RO membrane, but I will say that this is something we are investigating. So currently we offer brackish water RO membrane elements.
Okay. Do you have specific limits for RO feed water quality?
Brett, do you want to take it or do you want me to take it?
No, go ahead.
Okay, so at this point, what we've seen in the field is that when we're putting our elements into an existing RO system, there are some organics that are already being fed into that RO system, and our elements are being able to handle those organic levels better than conventional RO elements. So while we're still trying to determine exactly what those upper limits are for those different organic species for our membrane, right now we can say that we're following the same system design guidelines as conventional RO elements, but realize that there are a lot of systems out there that are already seeing elevated organic levels, and we are confident that our product can handle those organic levels better than conventional RO elements.
Thanks, Elko. Another chemical question. What type of chemicals are needed for regular operations? Biocides, antiscalants?
Yeah, I can jump on this one. Oh, okay. Go ahead, Brett.
A lot of experts.
Yeah, I mean, I would say, so antiscalants are definitely needed. You know, we haven't solved scaling yet for raw membranes. I don't know if that's possible. So you would still need antiscalant. Biocides, I've seen some people use them. If they're currently using them on an existing installation, I would keep it in, try it first and then remove the biocide. But, ultimately, if you're trying to save costs on biocides, then those, I would recommend trying that as well. You should have a lot less frequent cleaning than you would with a conventional RO membrane.
Thanks, Brett. The next question is the pre-treatment only to remove suspended solids?
Yeah, so I can answer that. For landfill leachate, typically you're mostly removing the suspended solids, but that's also why I mentioned the superfiltration. If you have really high strength leachate with high levels of COD and oil and grease, for example, I would highly recommend using something like superfiltration ahead of the membrane, because those can be an issue for conventional RO membranes. And then there's also usually pH adjustment ahead of your membrane system for helping to remove ammonia. So you want to lower the pH to do that. And then sometimes, like I mentioned, there's multiple passes. So for second or third pass, you might increase the pH if you're trying to remove boron. But those are, the typical chemicals I've seen used for leachate treatment.
All right, thank you. Okay, a different question, different type. So is there a difference in permeate output and flux between your 34 and 50 mil membranes?
Yeah, I can take this one. So in general, if you look at the element itself, yes, there will probably be a difference just because when you're using a thicker feed spacer, you'll have a little bit less membrane area in the element itself. So that could potentially, mean that you're operating at slightly different flux, perhaps. But the main difference in using these different feed spacers is really looking at the type of feed that's going into the system. If you've got a higher strength leachate, you might want to look at a 50 mil element to provide a larger feed channel. So that's the reason for those two different element configurations.
Thank you. All right, next question. Do these membranes resist silica scale like the organics?
I can take that. Oh,
Go ahead, Brett.
Okay. Yeah, no, silica, you're similar. Yeah, you're going to have, if you have really high levels of silica, that'll need to be covered with an anti-scalant, anti-dispersant. So our membranes are really focused on the organics, and landfill leachate is, always going to have high levels of organics. So it's primarily, that's the primary benefit for our RO membranes. You want to say something else, Alka?
Yeah, I was just gonna add one thing. When it comes to inorganics, so dissolved salts, right? When those become super saturated, they're going to precipitate no matter which membrane is installed in the system. So that's why we say, when it comes to inorganics, the ZwitterCo RO membrane is going to perform very similarly to a conventional RO membrane. The real difference in our technology is geared more towards the organic constituents like Brett was mentioning.
Thank you. Okay, another question. Does your cost analysis take into consideration the disposal of the residue, specifically if we have contaminants like arsenic?
Great question. At this point, our cost analysis does not take this into consideration, but I would happily discuss, this with someone to understand what that is costing you, and we can certainly build that into the analysis.
Thank you. There are a few other questions we'll probably answer offline. Are there any, let's see, I've got a couple more, and if you want to send in a couple more, we have a few more minutes. My next question is, do I need to pilot with these elements first?
So I'll take that one as well. No, you don't necessarily need to pilot with these elements first. These, like I said in the webinar, these elements are designed to industry standard sizes, so they really are a drop-in replacement. So really at this point, what we've been doing as a company is we've been looking at if there's an existing site and they have multiple trains, for example, installing ZwitterCo RO in one of the trains makes for a perfect side-by-side against conventional RO elements. So that is probably a faster way to realize the benefits than if you were to do a pilot upfront, which is obviously going to cost you money and take time. So we're definitely in favor of installing a full train so you can see side by side against conventional.
All right, thank you. I think that about wraps it up. Those were some great questions. Thank you so much.